So, dito ngayon tayo sa extract application. So, una kong isolve is about beams. So, we have problem. Determine the reaction at the support of the beam shown in figure 15 8 EI is a show mass constant. So, we have beam loaded with 5 kN at the free end. So, unang gagawin is i-draw muna yung beam. So, we have 2 and 2. So, to draw the beam, go to nodal coordinates. So, this could be the start point, 0, 0. So, ito yan. 0, 0. Next is, we go with the roller support, that is 2, then 0. 2, then 0. Then, we have 4, then 0. So, automatic yung pag-update din ng illustration ng model for beam. So, next natin gagawin is, ilagay natin yung support. So, makikita natin dito sa problem na meron tayong hinge support at 0, 0 and a roller support at 2, 0. So, ilagay natin yan dito sa support coordinates. So, hinge is 0, 0. Then, we have 2, 0. So, makikita natin na meron tayong roller support o hinge support and a roller support. So, that's it. Next is, mag-assign tayo ng values for members. So, ito yan. So, click lang natin yung beams. Then, ito na yung lalabas. So, meron tayong tatlong members available. So, punta ako sa member 1. So, meron tayong 2 meters member. Then, makikita natin dito sa figure na ito yung mga code numbers. So, we have 6, 4, 5, and 3. Vertical moment. So, 6, 4, 5, and 3. Yung ilalagay natin dito sa code numbers. 6, 5, 4, then 3. So, yun. 6, 4, 5, and 3. Sorry. 6, 4, 5, and 3. 6, 4, 5, 1, 3. Then, since the problem given dito, sabi niya, na EI is assumed constant. So, pag EI is assumed constant, automatic yung E area, tsaka yung moment of inertia is equal to 1. Next natin ilagay is yung member 2. So, makikita natin dito na we have member 2 meter. So, this will be 2 meter. Then, the code for 2 is we have 5, 3, 2, then 1. 5, 3, 2, then 1. So, 5, 3, 2, then 1. Then, assume constant. So, 1 lang lahat yan. So, wala tayong member 3 hanggang member 2 lang. So, punta tayo dito sa loading. So, makikita natin this figure. Sabi niya, the beam has 2 elements and 3 nodes which indicated in figure 15.8b dito. So, the code numbers are 1 to 6 as indicated such that the lowest number is 1 to 4. So, which identify the unconstant degrees of freedom. So, this 1 to 4. So, ibig sabihin, yung last code will be 4. And we have the known load and displacement. So, yung load lang yung kukunin ko, yung ito. Yan, hanggang 4. And ito yung magiging last code. 4. So, lagay natin yan. We have 0. We have negative 5. 0, then 0. Then, the last code is kung ilang number of entries code. This is 4. Now, if you want to assign, you can use also the calculator here. So mag-open up yung Windows calculator. So, yan. So, kung gusto mo mag-convert, dito lang yan. Converter for length, volume, etc. So, So, from now, hindi ko muna gagamitin. So, punta ako sa paglagay ng units. Ayan. So, ito yung pagko-compute ng mga loadings depende kung anong load type yung andon. Pero ito lang yung concern ko. So, makikita natin na dito sa problem na yung 1, 3, and 4, lahat yan moment. 1, 3, and 4, lahat yan moment. 1. So, lagay ko dito, kilonewton meter. Kilonewton meter. Kilonewton meter. And the rest, so makikita natin, the rest will be 2, 5, and 6. Lahat yan vertical forces. So, kilonewton yan. Or you can use newton, depende. Pero gumamit ako ng kilonewton muna. So, kailangan kilonewton lang. Then, dito sa problem, makikita natin na di natin kailangan kumpitin yung reaction only for Q. So, assume ko lang na 0. 0 lahat. Kasi wala tayong kumpitin na reaction. Yung R. Then, click natin to para ma-save natin yung values. So, yung values is okay. Then, close natin yung program na yan. Next is, we need to save these inputs. So, click save and values. Click lang natin. After that, close. Yeah. Then, para view natin yung beam stiffness matrix, click mo lang to. So, makikita natin. Ayan. So, shoe beam stiffness matrix. Oops. Sorry. Then, click natin yan. So, automatic mag-update yung windows. So, tayin mo lang yan. Hanggang matapos yan. Ayan, no? Tapos na yung computation. So, nakikita natin na meron tayong individual member stiffness. Yung ganito, for every member. Pero ito wala na tanig na effect kasi walang member 3. So, only member 1 and 2. Then, makikita natin na ito yung structure stiffness matrix. So, na yan. Saan ka na magpakita ka? Ayan. So, check natin yan kung pareho ba talaga. Okay, pareho talaga yan. So, check natin ha. Ito. Yan. Dito naman. Okay. So, makikita mo nga pareho sila. 2, negative 1.5, 1, so on, 1.5, 0. Ayan. So, pareho sila lahat. So, yan na yung global structural stiffness matrix. Ayan. So, balik tayo ulit. Zoom in natin yan. Then, zoom in natin. So, i-clear ko lang yan. Clear. Para matanggal lahat yung nakalagay. Then, so, mag-update ulit yan. Windows. Ayan. So, clear na yung working system natin. So next natin gagawin is ipakita natin yung beam calculation, yung solution, tsaka yung result. So click lang natin to. Then automatic again, mag-update yung Windows. Kaya lang natin yan, yung matapos. So, I think tapos na. So, yan. So, makikita natin na ito yung computation lahat. So, dito, bababa natin yan. Ayan. So, medyo mahaba-haba yung computation niya. So, zoom out natin. So, ayan, ha. So, ayan. So, we have structural stiffness, yung kanina. Then, the displacement, solution, summary and iteration. Ayan. So, para yung concern lang ba natin dito is yung final. Pero ito yung solution lahat. So, yung final output is ito yun. Nakikita natin. So, we don't need to compute for R. So, yung concern ko lang. Sige ito. Ayan. So, same value yan with in displacement. Same value yan with the manual. So, makikita natin dito na yung D1 is negative 16.67 over EI. We have negative 26.67 over EI. And we have negative 6.67 over EI. And we have 3.32. So, same value with the manual. And if you want to compute for Q, so yung result ng Q, we have medyo may typo dito sa kaya mo na yan. Then, for Q, na-compute din natin, we have 10 kilonewton for Q5, and for Q6, we have negative 5. So, yung ibig sabihin dito is wala yan. So, yan. So, I think yan lang for beams. So, yan. Aralin nyo na lang, ha?